students. So in last lecture we see how to show hexagonal plane by using four different axes. Actually we continue that same lecture, and here we take first example. If we want to show the shaded plane, okay, and if we want to represent this plane, shaded plane, so how to represent by using these four axes. Actually, if we represent with four axes, that is called as Miller-Brevitz indices system. So, if we consider this plane, then in A1 direction, this is positive direction, and from this point, this is negative direction. So, unit distance is there and -1 distance is there. If we consider this is A2, so unit distance is again available, so this is 1. If we consider A3, this plane is not related to this A3 axis, so we consider that is parallel to this shaded plane, and that value becomes infinity. If we consider C is again not connected to this plane, and that value becomes again infinity. So our rule is taking intercept first and then take the reciprocals. So after taking reciprocals, 1 upon -1, 1 upon 1, 1 upon infinity, 1 upon infinity. So this value becomes -1, this is 1, 0, 0. And our last rule becomes, if negative value is there, then use bar symbol there, and for representation of plane, we represent that plane in parentheses. So this is our representation for this shaded plane, that is 1 bar, 1, 0, 0. If we take another example, if we want to represent this plane, okay, this shaded plane. So again, if we check the A1 distance, this distance is actually parallel to this shaded plane, so infinity. Then A2 distance, yes, available, that is unit distance, so 1. A3, okay, if we extend this in the opposite direction, that is negative direction, so in negative direction the distance is available, and that distance becomes -1. Okay, that distance becomes -1. If we take the next, that is C direction, actually C direction is parallel to this shaded plane, and so this value becomes infinity. Now our next rule is taking the reciprocals, so 1 upon infinity, 1 upon 1, 1 upon -1, 1 upon infinity. So values become 0, 1, -1, 0. Okay, and if we find out the planes, points of planes, so 0, 1, and for -1 this is 1 bar, and this is 0. So this is the representation for this shaded plane, that is 0, 1, 1 bar and 0. Similarly, if we find out, okay, if we try to find out the different planes, that is also possible. One more we check. Now if we want to find out this shaded plane, okay, so at A1, yes, value is available, unit distance, A2 is parallel to this plane, so this is infinity. A3, if we extend, then -1, negative direction is there, this is positive direction. So here negative direction is available, -1. Then C direction, C direction, that is C value becomes, this direction becomes parallel to this shaded plane. So again infinity. Next rule is take reciprocal. Then 1, 0, -1, 0. 1 upon infinity is 0. So 0. So taking in parenthesis, so 1, 0, 1 bar, 0. For negative 1, this is 1 bar. So this is the representation. Now if we actually one more example we already seen, and that was example once plane becomes -1, 1, 0, 0. Actually this shaded portion we consider in example number 1, example number 2, this is example number 3. Now if we compare the planes H, K, L and that values, 4 values. So this is 1 bar, here also available 1 bar, here also available 1 bar. This is 1, here 1, 1. Then 2 times 0, 2 times 0, 2 times 0. So in this way we say that if we take any plane, then intercept becomes these 4 intercepts only, and so it is called as family. So 1 bar must be there. If you take any plane, then 1 must be there, 0 and 0 must be there. Okay. So if we compare this with 3 axis and 4 axis, so 4 axis is more corrected due to this reason, because if we take any plane, then all values are same. But we already discussed in last lecture that if we take 3 axis, then this values becomes varying, and that is the reason why in hexagonal crystal structure the 4 values are required. This is the reason. Now consider we want to find out this plane. Actually this plane, if we want to find out the values for this plane, then this is A1 axis, A2 axis, this is A3 axis, and this is C axis. So if we take the intercepts in A direction, yes, required, distance is required, unit distance we consider here. So 1, positive 1. This distance is also related or needed. This in A2 direction, positive 1. If we take this A3, then in positive direction distance is not required, but if we go in reverse direction, it is negative direction, at this location some value may be there. And actually if we use our mathematics or some trigonometric equations, then we are getting this distance becomes actually half distance. This is not complete one distance, but this is half distance. So and negative direction, so minus 1/2. So this is negative A3 direction, and half distance is there, and so minus 1/2 is the value for A3. Then see, yes, complete one value, that is unit value, so 1, positive direction 1. Taking a reciprocal, 1 upon 1, 1 upon 1, 1 upon minus 1/2, 1 upon 1. We solve, then 1, 1, minus 2, 1. If we check this in parentheses, so 1, 1, 2 bar 1. These are the values for this plane by using this Miller-Brevis system. Okay, so in this way we finish our discussion for representation of planes in hexagonal crystal structure. Now we see representation of directions in hexagonal crystal structure. So here the directions which we show by using this 4 axis. Now in this system, first we find out by using 3 axes, that is by using Miller Indices system we find out the values of direction, and some formulas are available. Okay, and that formulas are used by converting it into 4 different axis system, and that system is called as Miller-Brevis indices system. And these indices systems are represented with U capital letters U, V, W, and small letter T. So U, V, T, and W letters. And if we know the values by using Miller indices system, that is 3 axis system, then we get small letters, that is U, V, W values, U, V, W, and if we know these 3 values, you substitute in this formula, and then you get these values U, V, T, and W, that is in Miller-Brevis indices system. If we take some examples, then you get a clear idea. Before that, I want to explain how use that 3 different axes in cubic system. I want to revise that part, and after that you get clear idea how to calculate the, or how to find out the directions. So if we take cubic system, for explanation, this is the cube. So actually this is U with W, or it is also represented A, B, C. Okay. So if we want to find out the direction from origin towards this point, towards this point, so this value becomes 1. Okay. In B direction the value is not required, so 0. C direction value is not required, so again 0. And we put this in square bracket. So this is the representation for origin to this point, this direction. Okay, for this direction we represent with square bracket and 1 0 0 values. Similarly, if we want to find out the values for this location, so this direction is there from origin towards the here, and in A direction value becomes 0, in B direction value becomes 1, in C direction value becomes 0. Okay. So U value becomes 0, V value becomes 1, W value becomes 0. In this case, U value is 1, V is 0, W is 0. Now we see for hexagonal crystal system. So if we consider this point and this is the origin, so how to find out this direction? So for this direction, this A1 distance becomes 1, A2 distance is 0, and C distance is 0. So the value becomes 1 0 0. And now if we use this formula, then for this formula U is equal to 1 upon 3. In this case, U is equal to 1, V is equal to 0. W is equal to 0. We substitute here. So 1 upon 3 into bracket 2 into U becomes 1 minus V becomes 0. So 1 upon 3. So answer is 2 upon 3. So U becomes 2 upon 3. In this way, if we find out V value, so V is equal to 1 upon 3 minus U becomes 1 plus 2 into V becomes 0. So 1 upon 3 minus 1 plus 0. So answer becomes minus 1 upon 3. So this is V. If we find out T value, so T is equal to U becomes 2 upon 3, V becomes minus 1 upon 3, minus sign is there. So 2 upon 3 plus minus 1 upon 3. So minus 2 upon 3 minus 1 upon 3. So minus 2 upon 3 minus 1 plus 1 upon 3. The value become minus 1 upon 3. This is T value, and W value becomes W is equal to 0. So these are the values. So for this case, if we find out Miller-Davis indices, the values becomes 2 upon 3, then minus 1 upon 3, minus 1 upon 3, and 0. Actually, we are getting this intercept. Now, this is U, V, T, and W. Now, if we take our one rule is that take integral values. So we multiply with 3. So our values becomes 2, minus 1, 0. And in place of minus 1, if we substitute bar, so 2, 1 bar, 0. And we take this in square bracket. So this is our final direction for this location in case of hexagonal crystal structure. So 2, 1 bar, 0. This is first example. coordinates, direction for this location, direction for this location, then how to go there. So if we extend this A1 line in backward direction or negative direction, then the point comes here, then positive C direction. So in this way, we reach at this location and we get this direction. We get this direction. Okay. So negative A1 direction and then positive C direction. So we get there in this point. So before that, we use our three intersect. We use our three directional system and find out u, v, w values, and then substituting here we get all four values. So for this direction or A1 direction if we consider, so negative direction we require. So -1 in B direction, the value is not there, so 0, or this is actually A2 direction, and this A3 direction is not considered in 3-axis system, only C direction we consider, and C direction is required, that is 1. So this is in case of 3-axis or Miller indices system, and now we convert it into this system, Miller-Davis indices system. So this is U, V, W. So U is equal to 1 upon 3 into bracket 2 into -1 minus V, that is 0. So value becomes -2 upon 3. This is our first value. V becomes 1 upon 3 minus in bracket -1 plus 2 into 0. So 1 upon 3 plus 1 plus 0. So answer becomes 1 upon 3. Then T becomes minus in bracket u plus v, or u is -2 upon 3 plus v, that is 1 upon 3 minus plus 2 upon 3 minus plus minus 1 upon 3. So value becomes 1 upon 3. So this is the value for T. What is W? W is equal to W, which is equal to 1. So in this way, we are getting the directions for Miller-Davis system becomes -2 upon 3, actually not in square bracket, these are the intercepts. So -2 upon 3, then 1 upon 3, 1 upon 3 and 1. Now by using our rule, take integer value, so multiply with 3, -2, then 1, 1, 3. Then negative values by using bar, so 2 bar in square bracket 1, 1, 3. In square bracket 2 bar 1, 1, 3. So in this way we are getting points for this. Okay. And now we use or we see the last example. If point is located at another location, now if we want to find out the direction for this point or this point, so how to go there? So from origin, if we start in this A1 direction, so here, then from A1 to in this A2 direction like this, and from A2 to this C direction like this. So in this way we reach at this location, and that is Miller indices system, 3-axis system. So in case of A1 direction, yes, it is needed. This one distance. In A2 direction, yes, it is also needed. It is 1. And in C direction also distance is needed. That is 1. So 1, 1, 1. If we take intercepts, reciprocal, then again 1, 1, 1, and no negative value is there. So actually this becomes u, v, and w values. If we substitute here, so u value becomes 1 upon 3, 2 into 1 minus 1, and which is equal to 1 upon 3, 2 minus 1. So 1 upon 3, 1, that is 1 upon 3. U becomes 1 upon 3. Then next becomes V. So V is equal to 1 upon 3 minus U becomes 1 plus 2 into 1, which is equal to 1 upon 3 minus 1 plus 2. So 1 upon 3 plus 1, that is 1 upon 3. So 1 upon 3 is the value for V. And if we consider T is equal to minus U plus V. So which is equal to minus 1 upon 3 plus 1 upon 3, which is equal to minus 1 upon 3 U becomes 1 upon 3 plus 1 upon 3, so minus 2 upon 3. This is the value for T. And finally W value becomes W is equal to W, that is equal to 1. So in this way our values becomes U becomes 1 upon not in square bracket. The intercepts becomes 1 upon 3, then 1 upon 3 minus 2 upon 3 and 1. If we take the actually integral values, then 1 minus 2 3. So 1 2 3. This is the square bracket. So this is the representation for this point. Okay. Now if we want to check this value, okay, or whether this is true or not, if we want to check, then how to check? So this is actually U, V, T, and actually W. These 4 directions are there: A1, A2, A3, and C direction. So in A1 direction, one distance is available. So we go from here to here. Then in A2 direction, this direction, one distance is available. So we go from here to here. Then in A3 direction, 2 bar. So this is positive direction. So we go in this direction, negative direction. And this is unit distance. But here 2 values are available. So we go 2 times of this distance. So from here to here and here to here. So in this way we reach at this location. So this is our 2 bar. And what is our last value? Last value becomes 3. This is actually unit distance. So we go from here to here, that is unit distance. But after that we go again 2 times more of this distance, because 3 value is there. So we reach from here to here. And if we extend this direction, this direction must pass through this point. And in this way, it is true that this is true. These values are true. Okay. So in this way, we are getting the direction by using these 4 indexes. In this way, today we finish this lecture here, and we learn how to show the or how to represent the planes, and how to represent the directions in case of hexagonal crystal structure. I hope you understand these topics, and we finish here this topic. So thank you, and please subscribe my channel for seeing the next videos.